last week or two, we've put down some studies on our social media and on our blog that I have taken great interest in, and I know you have as well, because we've been having some messages back and forth on this stuff. And one of the ones that always tends to hit home, is crossover gait and foot placement and pelvic posturing and stacking of joints and whatnot, which is kind of the hardcore stuff about gait, if you will. And there was a couple articles here. We'll have them all in the show notes. And this one was on foot placement. And as I had said, foot placement matters. Well, of course it matters. And we all talked about if the foot is inside, if you were to drop 2 lines down from the center of axis of the hip joint, and you were to plumb line that down, and if you put your foot inside that line, medial to that line, you'd be doing what we refer to as a crossover gait. And if you're outside that line, you're either wide base gait for one reason or the other, neurologic disease, disorder, or who knows what. But you'd like to stack the joints over top of each other, foot underneath knee and knee underneath hip, center of body mass in between those two, and moving gait-wise through that, trying to keep the center of body mass inside the two train track lines, if you will, of gait foot placement. And when we get some weakness of the core, weakness of the glute medius, and we start drifting sideways, the foot placement starts going inside, we tend to step on a more narrow line, or on a line, completely on a line, and creating a crossover gait, which tends to challenge the system a little bit. We'll go on a little bit later on the possible economy of this, but this one was this one talked about let's see, foot placement, and that it should be relatively beneath the stacked knee and hip, and the center of mass should be maintained between those two. So let's see here. This brings in a lot of other things: premature heel rise, toe walking, excessive heel loading, and hopefully we can get into that just a little bit as we move forward here. Let's see, medial lateral stability can be efficiently controlled through appropriate foot placement. This study hypothesized that humans control medial to lateral foot placement through swing leg muscle activity, basing this control on the mechanical state of the contralateral stance leg. So in this study, and Ivo, you can jump in at any point here, during unperturbed walking. So in this study, they were jarring people or perturbing them, if you will, and then they were doing some control studies as well. During unperturbed walking, greater swing phase, glute medius activity was associated with more lateral foot placement. And increases in glute medius activity were most strongly predicted by increased medial to lateral displacement between the center of mass and the contralateral stance phase. So we've always talked about, in particular, or in relation to the crossover gait, the stance phase leg in glute medius activity. And when the glute medius is active, it helps maintain the pelvis in a neutral posture, or in a neutral horizontal plane. And if the glute medius is on, it holds that pelvis in that placement, which stops some frontal plane drift over that stance phase leg. Conversely, when the glute medius is weak, the contralateral pelvis drops, the stance phase leg pelvis, hemipelvis tends to shift laterally over that leg, creating a lateral hip placement over the foot placement in relative terms. So you're tending to cross over gait. This study is talking about the swing leg, and that the glute medius needs to be looked at there as well. That when you're in swing phase, if the glute medius isn't working, that leg will adduct, in other words, move towards the midline. And you need to have appropriate amount of glute medius tone in order to keep that leg swinging in a straight line, so that when the foot hits the ground or hits the target, you're in a stacked position. We have not talked about this until this very point in these articles here. And the issue has been one that we always thought that it was the stance leg. One of our mnemonics and phrases is that when the foot's on the ground, the glute's in charge, and when the foot's in the air, the abs are in charge. But this article here tends to suggest, well, the abs may be in charge, but you better have the glute medius in charge, otherwise that leg may drift. Now, I might argue that if the pelvis is completely level and the hip is moving cleanly, you should have a relatively unencumbered and a hip swing or pendulum effect. But this article tends to suggest, and it may just be because of the mass of the limb and movement of the body, that the leg may move towards the midline, and without glute medius activity to hold it in that perfectly vertical or vertical posturing to get a nice clean swing or pendulum-like effect, you need the glute medius on. What are your thoughts on this? Because I've got a little bit more, but I'd like to get your input on this at this point so far.
Well, there's a few things to think about. First of all, I want to emphasize or let everybody know this article is a great article, and it's a free full-text article. So we expect you to go online, we're talking about the Rankin article now, and go ahead and download this and read it. Not that the experiment is anything like super duper enlightening, but all the other ancillary supportive material in it is absolutely fabulous. And if you're interested in neuromechanics more, there's a great book called The Neuromechanics of Human Movement. It's by a guy named Roger Enoka, E-N-O-K-A, who's a real neuro guru, talking about that. So what they're talking about is, now we know during normal gait, the gluteus medius is pretty much active when the foot's on the ground. It works in conjunction with the contralateral quadratus lumborum to maintain the pelvis being stable or level. This is Porterfield and DeRosa's work. It's been around for years. We've talked about it a million times here on the pod as well as the blog. What they're talking about in this particular one is the swing phase leg. And what we need to understand is, generally speaking, from most of the research that we've read, there's not a lot of activity in the gluteus medius during the swing phase, at least from the EMG studies that I've looked at. And I'm looking at one right now from Virginia Gait Research Lab that's going on that. And basically what it shows is during stance phase we're seeing a lot of gluteus medius activity, and during swing we're not seeing a lot. Now, that's in walking. In running, that's totally different. In running gait, we will see gluteus medius activity to help advance that contralateral leg.
So that tends to that tends to go against what we're talking about here in this article, right?
Well, it doesn't necessarily go against it. It just means that maybe they weren't looking at something sensitive enough, or when they were looking at the registration. So it's not like there's zero activity. There's less activity. So if we're looking at micro voltage, okay, which is what we're looking at when we look at EMG, and let's just take an arbitrary number of 100 microvolts for general activity, you might only see 20 during swing phase, whereas you're seeing 80, 90, 100 during stance phase. Follow what I'm saying? So we're not saying that. They were just being more sensitive, or you just dial your sensitivity up or down respectively when they're looking at the activity. So it's interesting that they were looking at this. Now, to say that when the leg is more abducted, which a lot of times it's going to be when you're perturbed, right? If you're perturbing walking, I'm interfering, moving the treadmill, stimulating you from one side, you're going to try to go against that. To find that there's more activity, that's really not surprising. So if people have poor economy of gait for whatever reason, whether it's pathological, physiological, whatever, they're going to have increased gluteus medius activity, which is one of those parameters that's going to drive up the increased metabolic need of the individual. In other words, they're going to burn more energy because they're not as efficient. So that's really not a big earth shaker. At least it wasn't for me when I read through the paper either. The interesting thing here was they were talking about the actual foot placement, and that depending upon where the foot was going to be, you were going to alter activity significantly. Is that correct? Am I reading it correctly?
Yeah, I think so.
Yeah. So, in other words, if my stance phase leg has a foot placement, like let's say with the foot abducted more or adducted more, in other words, externally or internally rotated more, that is going to affect the contralateral leg and swing. And if you think about that, that really kind of makes sense, because if you just walk, put your hands on your gluteus mediuses, externally rotate your legs and walk along, you'll definitely feel different activity than if you totally internally rotate them and walk along. So foot placement of the contralateral side is going to affect G-med activity. Now I'm sure somewhere in the cerebellum or the cortex, the two G-meds are connected, through central pattern generators or something like that. So the activity in one is going to be fed into the cerebellum compared with the information that's coming from that leg as well as the contralateral leg, so the brain knows how to respond. And that's that, dorsal versus ventral spinocerebellar system that we hammer on here all the time, talking about, efferent feedback and monitoring that, what's going on. So that's another one of those multiple redundancies built into the system. But overall, just I thought it was cool. Well, and I haven't seen a study talking about this in particular. Sorry to interrupt, Sarah.
No, it's good. And on that topic, I'm glad you went there. The glute medius may be connected somewhere in the cerebellum, and those pattern generators. I love that statement, because if you think about it, folks, maybe both of the studies I've referred to have something going for it. You just have to look a little closer, maybe between the lines. What do I mean by that? Well, let's imagine you put your right foot on the ground. You don't have enough glute medius activity. The pelvis starts to drift to that right side, and now the pelvis is kind of swaying over a little bit further over that foot, and now the weight-bearing load is going to be more on the outside of the foot, which tends to be one of those causes of a lot of the lateral foot pain in a lot of runners, because if they're crossing over, you're going to strike on that outside of the heel and outside of the midfoot, and pronation phase is going to have to be rather excessive and prolonged, or you may not even get over to medial toe off. But to stay on topic, if you're drifting medially over that right side with the pelvis, because that glute medius activity is down, you got to remember that, and as we've talked about this in the crossover gait, the swing phase leg is going to move medially as well. Just because the pelvis is moving, the leg is going to adduct, and this is where you get the scraping of the swing phase leg against the stance phase ankle, inside ankle. This is what drives the crossover gait. And so the brain, if they're both talking about both glute medius, it may say, look, pelvis is drifting to the right. We better increase the swing phase glute medius activity to abduct the leg to reduce some of that crossover or to stop some of the kicking effect. This may be some of the circumducting effects that we see in folks who tend to get into this crossover gait. You've got to circumduct the leg around the stance phase leg each time, otherwise you are going to be kicking your Achilles or at least your medial ankle. So maybe the two of them are connected, and that's the between the lines thinking that if one side's dialed back, you better increase the other or the swing phase leg to abduct the leg to try and reduce some of this. But unfortunately, they tend to get into a cycle. In order not to fall over, you got to cross over on the next step, and then you got to cross over on the next step. So I do think there is got to be some dialogue between the two and some communication in order to reduce this. But target placement or foot placement is really important. Why is that? Well, think about it. If you're putting your foot down and your knee and your hip are stacked right over that point, you're probably going to be able to get to a nice foot tripod, as we've referred to it as. But if the leg is adducted, meaning drifting medially, you're going to strike laterally on the lateral heel, lateral forefoot, and then to get over to that medial tripod, you're going to have to pronate really hard and move into that valgus-type posturing at the foot to try and get that tripod down, which is going to be a rather abrupt and prolonged pronatory phase. So you want this glute medius, I think, talking. The question is how much, and as I've said, are they talking together? I'm starting to think that maybe you're right, that there's a deeper dialogue going on here than either one of these articles may suggest. So.